Right. So today we're going to talk about how you can actually run low-cost, high-performance training and inference workloads on Amazon EKS. And the first thing we're going to touch upon AWS Neuron capabilities, and then we will delve into what it takes to actually run these workloads on Amazon EKS and what components are required in terms of plugins and infrastructure. And then we also delve into an end-to-end a model like Llama 3.8b model deploying on Inferentia instances, which is comparable with the GPUs. And we also have a small demo to show you how you can actually scale these inference workloads across multiple nodes using Ray and AWS Neuron. Right, so at AWS, and this is one thing that we consistently hear from the customers, the biggest concern is around how do we actually reduce the cost for the raising, AI workload demand in terms of both training and inferentia. And the second thing is about, how to actually overcome the challenge around the scarcity of the GPUs. So with that, AWS actually built AWS Silicon, which allows you to actually run low-cost, high-performance training and inference workloads on EKS, SageMaker, or various other platforms. So starting with AWS Trainium. So we launched the AWS Trainium specifically for running the training workloads, and this provides 50% cost savings with a comparable EC2 instances, which is mainly designed for running high-performance training workloads. Moving on to AWS Inferentia 2. This is mainly designed for running your large language model inference, and which actually saves costs around 40% with the comparable EC2 instances. And then finally, AWS Inferentia, which offers up to 70% lower cost per inference compared to the other EC2 instances. So this is mainly used for the deep learning models. And a lot of our customers today are leveraging both Trainium and Inferentia to run their workloads on Amazon EKS. So let's talk about a little bit what it takes to run these training and inference workloads on EKS, right? So when it comes to the Kubernetes, you start to think about, it's too complex to run these workloads, but it's not the case. Trust me on that. So all that you need with deploying the Amazon EKS, it's a Kubernetes platform. It's a fully managed control plane, more efficient for running your training and inference workloads. And in terms of scaling the workloads, actual workloads instances, you can use auto-scaling like Carpenter, allows you to scale your nodes. And layer 2, to deploy your workloads on Kubernetes, and we highly recommend using Ray and using KubeRay operator. You can define a small YAML, and then you can deploy your both distributed training and distributed inference workloads using Ray YAML. And then in addition to that, using the VLLM, which is most popular in terms of batch inferencing for the high performance and low throughput. So using VLLM, you can leverage your inference much faster. And to work with AWS Neuron Inferentia instances, we have Neuron SDK, which is a software toolkit, helps you to actually work with both AWS Trainium and Inferentia instances. And one layer down, you can run these workloads using GPUs today, and you can run both training and inference workloads using Trainium and Inferentia as well. But to run these workloads specific to the Trainium and Inferentia, you need a couple of plugins. And to start with, Neuron Device plugin. It's similar to the Kubernetes device plugin, specific to GPUs. And the Neuron Device plugin allows you to expose your Neuron cores to Kubernetes API server, and so that your pods can be placed onto either Trainium or Inferentia instances. And the second one is a Neuron scheduler, which is mainly designed, it's an extension to the Kubernetes scheduler, mainly designed to place more number of pods in a larger instances where you really want to choose on a fewer cores than the available cores on the EC2 instance. And the Neuron node problem detector is the next one, which is really cool in this case. It actually detects for the hardware failures within your Trainium and Inferentia instances, and then restarts and creates, spin up a new node to replace your workloads. And finally, the Neuron monitor, which allows you to actually expose all the metrics to either Prometheus or a CloudWatch. You can look at how the Trainium Inferentia is being used in terms of the the core's usage. And finally, the last one is Elastic Fabric Adapter. Especially when you are thinking about running distributed inference or a training, you really want high performance and high throughput, which you can achieve by enabling the EFA and distribute. Say, for example, Llama 3.1405B model, you can't fit into a single node, but you can do the distributed inference across 4 nodes. Now let's talk about how you can actually deploy Llama 3 8B model. When you look at the stack, it's so simple. You have the EKS cluster on the top, and we have Carpenter Autoscaler, which actually spins up the nodes. But to deploy, once you deploy your inference workload, say in this case, Llama 3B instruct model, 8B instruct model, and kubeRay operator spins up a Ray head pod and Ray worker pods. And when it requests a Ray head pod, as you can see, it is landing on M5 XLarge, it's x86 instance. But for the actual model, is deployed on one of the worker pod on Inf2 8XLarge. So Inf2 8XLarge come with 1 neuron device and 2 neuron cores, which is sufficient to run your Llama 3 8B model. But then the question comes to the auto-scaling, right? When you have more number of inference requests comes, can one instance can handle? Not necessary, it does. But in this case, Ray provides this auto-scaling feature where it can create multiple replicas. So if you have larger instances, it can create the replicas within the same instance. But in this case, we're using 8XLarge. So Carpenter automatically scales your nodes based on your need. And both Ray and Carpenter works together to scale your replicas. So with that, I'm handing over to Ratnapam, who is going to talk about the code snippets.
Yeah, sure. So in this one, and then again, this is not the by any means the full code snippet. For that, we have a slide where you can basically scan the QR code to get access to the full code base. But this is a snippet of the Rayserve YAML. So it is like as easy as applying this YAML file. And there are 3 sections highlighted here. So the first one is that we are defining the worker node group spec under the Ray cluster config. So depending on which version of Ray you are using, there might be a slight variation of this. But for the most part, it will be like this only. One important thing is for the horizontal autoscaling across nodes, you need to specify the underlying neuron cores. Since you are using Inf2 8XLarge instance in this demo, we are just requesting for 2 neuron cores. And then right below that, we are making use of the Kubernetes constructs like node selector and tolerations to make sure that the Ray worker pods actually land on the Inf2 instances. And then on the right-hand side, we do have the bit for the auto-scaling, where in this demo, we are using Carpenter, which is a just-in-time autoscaler, equivalent to the cluster autoscaler. So by looking at this resource and the requests, Carpenter is able to provision new nodes for your Ray workloads. So when you are running like inference workloads, you want to monitor the underlying neuron usage, right? So within the Neuron SDK, there are some useful tools for you that are available to help you with that. Neuron LS will list all the devices, underlying neuron devices, and then you can also monitor the runtime utilization using something like a very basic command like neuron top. So with that, we will show you a quick demo. So this is the website that we have under Data on EKS project. Again, the link and the QR code will be in the later slide. So here we are housing all of our inference and training related patterns, be it on GPUs or Inferentia. So for this particular demo, we are, this is the documentation. So we are making use of the VLLM with Rayserve and EKS using Carpenter on Neuron. So if you go through this documentation, so this is the architecture that we just looked at. And it's pretty simple to deploy this blueprint. It's all Terraform based. So once you deploy the cluster, it not only creates the EKS cluster, but also adds all of the different add-ons that are needed. And this is the observability bit. So using CloudWatch, you can monitor the neuron usage as well. So let's now deploy a Ray cluster. So on the terminal 1, we are just applying the the RayServe YAML. And then once we have done that, then it takes like, depending on how much bigger your container image is, it takes a while to get the Ray worker pods up and running. Once those are up and running, you can see in the terminal too. And then because VLLM is compatible with the OpenAI, we are making use of the OpenAI Web UI deployment. And we are doing a port forward to our local port. And once you do that, then on the number 4 terminal, we can basically monitor the neuron usages. So, yeah, and in the next, so as you can see, the neuron core utilization right now is at 0 because we are not running any inference workload now, right? On the next screen here, this is the Open Web UI browser. We are basically selecting the model. And after that, I am writing a prompt here. And basically what's happening behind the scene is this service from OpenUI is talking to the underlying Ray service behind the scenes. And then it is going to the inference endpoint, which is deployed on EKS. So once I send the prompt, we can see the streaming output coming back from the model. And if we want to look at the neuron utilization right now, we can see that right now, as the inference request is coming in, the neuron utilization is increasing, right? And again, we are using the inf to 8x large instance, so we have like 2 cores and 1 device. But depending on your instance type, you will see more cores available here. So now the output has been completed. And again, this is Open Web UI, so you can basically modify different parameters and modify your prompts. So this was a quick demo of how easy it is to put together this inference architecture using Ray, Amazon EKS, and VLLM on Neuron. Thanks.
Yeah, thank you very much, everyone. So if you want to get started, that's the portal. That's a QR code. And you can, it's a few steps to deploy your workloads on Amazon EKS, both for Neuron and GPUs as well. Yeah, that's it. Thank you very much.